Hello, this is Sadiq Raufan with the presentation of the software engineering project AlgoViz. AlgoViz is an iOS mobile application that is developed to provide an interactive visual representation of various sorting techniques that are applied to an array or list of elements. It can visualize all the popular sorting algorithms including bubble sort, selection sort, quick sort, and merge sort. Now the basic question arises, what is an algorithm and what is sorting? So going by the definition we have in mathematics and computer science, an algorithm is a finite sequence of well-defined computer implementable instructions used to solve a class of problem or to perform a computation, whereas sorting is any process of arranging items systematically. So we can say that a sorting algorithm is an algorithm that puts elements of a list in a certain order. Now we have the UI UX designing, that is the user interface. The whole UI UX designing was done in the XCode itself in the main storyboards, as you can see below. And we have now the high level functional description. Now as you will see, the app will have two sections, the algorithm section and the about and feedback section. And here's the functional block diagram, and here's the screenshot of the actual application. And you can see here's the first section, the algorithm section, and the about section, and here are the code snippets provided. Now let's run the code in the simulator itself, XCode. So here is the simulator and here is XCode, and in the simulator here is our app AlgoViz. Now let's run it through XCode. So upon opening we see that we have to first enter a list of integers and then select the preferred algorithm. So first let's enter any random list, let's say 14, 23, 28, 5, 31, 35, 20 and 9. Let's select bubble sort first and see how it works. Now you can see the visualization will start, and it has started. And we all know how bubble sort works. It takes the biggest element of the array and places it at the end of the array. And as you can see, 35 and 31 have been placed, but it's quite slow. It's because it is having a time complexity of n square, which is much slower, and it is slowly sorting the array. And now the array has been sorted. Now going back to the home screen, let's sort the same array with selection sort. Now the visualization has started, and we also know that how selection sort works. It takes the smallest element and places it at the front. 5 has been placed, next 9 will be placed, next 14, and slowly the whole array will be sorted. See, 9 has been placed. Now it is also slower because its time complexity is also n square. And it's about to be sorted. And it's sorted now. Now let's take another input, going back to the home screen. Okay, let's take another input, say any random numbers, 11, 22, 14, 6, 4, 17, 26 and 9. Now let's choose quick sort. Now the visualization has started, and we know how quick sort works. It takes an element, a pivot element, and places it at the correct position and sorts the element left to it and right to it accordingly. You can see the pivot element was 11, and all the elements to the left of it were smaller than 11, and all the elements at the right of it were bigger than 11. You can see it is very fast compared to selection sort and bubble sort, because its time complexity is big of n log n. So the list is sorted. Now going back to the home screen, let's sort the same array with merge sort. Now merge sort works with divide and conquer. That is, it divides the array in smaller and smaller chunks, sorts it, and then merge them again. As you can see, half array has been sorted, now another half is being sorted, and now the other half is also sorted. Now it will merge both the arrays, and the whole array will be sorted now. Its time complexity is also n log n, but it also takes an extra space. Now going back to the home screen, here's our app and here's the info and about section, and we can quit our app easily by going back to the home screen. And that's it. Thank you.